What if I told you that our planet is spinning faster than ever recorded in human history, and scientists have no idea why? This strange phenomenon is already changing the length of our days, and it could have consequences far beyond what we imagine. In recent years, scientists have been noticing something extraordinary, and slightly unsettling. The Earth, our home, is spinning faster than usual. This isn't just a tiny variation that goes unnoticed. Atomic clocks have confirmed that our days are becoming shorter, by milliseconds, on multiple occasions. On the 5th of August 2025, our planet's rotation sped up again, making the day shorter than the standard 86,400 seconds we've all taken for granted. In fact, between the 22nd of July and the 5th of August, Earth completed its rotation up to 1.6 milliseconds faster than normal. To put that into perspective, it's like the entire planet suddenly decided to fast-forward time, something we can measure, but cannot yet explain. A phenomenon that began in 2020. The first signs of this unusual acceleration were detected in 2020, and while Earth's rotation naturally fluctuates due to factors like seasonal shifts and geological activity, the persistent speed-up is new, and puzzling. The shortest day recorded so far in 2025 occurred on the 11th of July, and if the trend continues, we might be heading towards a future where we need to adjust how we measure time itself. Why does Earth's spin change at all? In normal circumstances, our planet's rotation can be influenced by a variety of natural forces. Tidal effects from the moon. The moon's gravity subtly pulls on Earth, affecting how it spins. Movements in Earth's molten core. The shifting liquid iron deep inside the planet can alter our rotation. Changes in oceans and atmosphere. Large-scale climate patterns, such as El Niño or La Niña, can move huge masses of water and air, redistributing Earth's mass. Glacial rebound. As ice melts and land masses adjust, the planet's weight distribution changes. While these processes can cause minor fluctuations, none of them fully explain the sudden and sustained acceleration we're seeing today. The mystery deepens. Leonid Zotov of Moscow State University summed it up simply: nobody expected this. Even with advanced models, scientists are struggling to pinpoint the exact cause. The acceleration trend appears to be a combination of multiple subtle influences acting together, but there's still a gap in our scientific understanding. Could it be linked to long-term climate change altering mass distribution? Could shifts in Earth's magnetic field be subtly influencing its spin? Or is there an entirely new geophysical process we've yet to discover? At this stage, the answer is uncertain. Why this matters? You might wonder, does a few milliseconds really make a difference? In everyday life, probably not. But for global systems that rely on ultra-precise timekeeping, like GPS satellites, internet networks, and financial markets, even a fraction of a millisecond can cause problems. If Earth continues to spin faster, international timekeepers may have to introduce a negative leap second, the opposite of what we've done in the past when adding leap seconds to slow our clocks down. This has never been done before and could introduce major challenges for systems not designed to handle it. Potential implications. Navigation systems. GPS relies on the exact timing of signals. Even small changes could disrupt accuracy. Financial trading. High-frequency transactions are timestamped in microseconds. A leap-second adjustment could cause chaos. Space operations. Spacecraft navigation depends on precise Earth rotation data. Scientific measurements. Climate data, astronomical observations, and physics experiments rely on a stable time standard. For Europe in particular, home to critical space agencies, satellite networks, and advanced communication infrastructure, such changes could have significant ripple effects. A challenge to our concept of time. Perhaps the most fascinating part of this discovery is philosophical. Time, as we measure it, has always been tied to the rotation of our planet. If Earth's spin changes, even subtly, it forces us to confront the idea that time is not as fixed as we think. Our ancestors looked at the sun to measure days, now we use atomic clocks. But the fact that we may need to adjust those clocks not because of a human error, but because the planet itself is changing pace, is a humbling reminder that we are part of a dynamic, ever-changing system. For now, the mystery remains unsolved. But scientists around the world are watching closely, knowing that every millisecond could bring us closer to understanding this strange acceleration, and what it might mean for the future. If you want to stay updated on the latest space, science, and Earth mysteries, hit the subscribe button, ring the bell, and share this video. The Earth is changing faster than we think. Let's explore the reasons together.